Hi, this is Abdulaziz Khan, and basically, I got a message on my YouTube channel, kind of comment about the waveguide losses. So, even though we don't use waveguide a lot, in most of the links we don't use waveguides. But because someone has asked me, so I need to put it here. So if you see here this symbol, this is basically, if you see here, this is antenna coupling unit. So antenna coupling means that anything that you use between antennas or between your system and the antenna, because if you see the placement, this is your indoor unit or this is your transmitter receiver. This is connecting to this box, and then this box is going above. If you see, we can even click double click this box and it brings out a transmission line. So this antenna coupler is, if you have been working on very big links, the links which are like 7+1 type of links, uh, which are not, you can say they are not simple link, they are a kind of backbone type of link. I mean, they are used mostly, whatever I know is they are mostly used in countries like Africa, because they have very less fiber, so they use a lot of microwave. So these are two things where you can put extra losses in path loss. One is this transmission line. The transmission line, if you see here, you can even have, I'm not sure if I have okay, I have something like I also have some things. So like for example, if you have some kind of waveguide or phone related cable or whatever cable you are using, you can put it here. So it has a loss of per 100 meter. So you, for example, if you select this cable, then you put a, for example, you're using a 50-meter cable. So you know now that you have a TX line loss of 31 dB, and then you can add a connector loss as well. So here also, for example, you have 45 meter. So in this way it will calculate everything. But generally for general links which don't have these kind of special cables, we don't put these kind of big values. Generally we put very small values, because the kind of cable that we use, like if you see these waveguide, they are in, like it's, for example, this is 5 dp per 100 meter. So in the same way you can see that some of the cable have a bit lower loss, like this Android cable is has only 13 dB of loss. So but generally if you see, we don't put this loss here. uh, if someone is hearing to my video, and he is, I mean, he's listening to it carefully, then I would like him to give a comment that why don't we put these losses in normal link. Now coming back to this again, so these losses are basically, you can say that if you compare, I mean, this loss with this cable loss, you will see the difference. There's a big difference. I mean, okay, I don't have any internal conversion unit, so it will not come. Generally, this is a kind of a big hardware where there are a lot of filters and this and combiners and a lot of things. I mean, so there may be, like, for example, circulator, transmission switch, transmission filter, then there's receive hybrid, then receive filter, and other receive losses. So what I will say that this is not quite straightforward, and um, it is usually what I have learned that this is because, when you are putting a kind of big uh, if you are putting a kind of big waveguide or a combiner, branching and combiner kind of big thing, then what you have to do is that you have to calculate the losses, because you have to physically, I mean, because you don't know, it's a kind of mechanical thing, this branching or and splitting. So there may be some physical issues, I mean, when you are putting it. So that's why when you put it fully, then uh, you use some kind of meters, and then you take the exact losses of different parts, and then you put those losses here. So coming back to the main question, because the main question which was asked was about um it was basically about this waveguide. So for example, if we are using electrical waveguide, then that waveguide should be in some specific kind of frequency, because when we use a waveguide, generally in the indoor unit, it is either a fully outdoor unit, or the indoor unit, we put the indoor part of the unit indoor, but the only the antenna is outside. I mean, there is no audio here. The audio is, you can say, part of indoor unit. So for example, if you are using a 8 gigahertz microwave, then the whole 8 gigahertz is coming from the indoor unit, and through a waveguide we take it to the antenna, and we just put it directly on the back of antenna. So the transfer power here is quite high. That is why we can take care of this kind of big loss. Like, uh, for example, if you see here, it's a 14 dB loss per 100 meter. Some like this 10 gigahertz Andro helix cable, it has a 62 dB of loss, which is quite high, but I mean, this is what it is being shown here. So coming back to the main point is that if we are putting a waveguide, then in that case, uh, as I already told, that we need to select the waveguide here, and then we need to put the approximate length, almost exact length we need to put here. So it will calculate as on its own, I mean, and then we can add the connector losses if required. So I hope that uh, I am understandable. I mean, and mm, so let me finish this. I hope this video should be useful for some of the guys, and if you still have any question, then you can ask the question from me and I will reply. So see you in my next video, and okay, goodbye.